In this video, I am going to show how to analyze a truss using method of joints. So this is the truss. You can see there are three members A, B, B, C and AC, and dimensions are given in this picture 2 meters and this length is 2 meters, and there is a horizontal force at B of 500 Newton, and this angle is 45 degrees. And at A there is a support, it's a pin support, and at C there is a rocker support. At first we have to look at three major theories. So first one is if a truss is in equilibrium, then each of its joints must also be in equilibrium. Second one is it is necessary to draw each joint's free body diagram before applying the equilibrium equations. Third one is the joint analysis should start at a joint having at least one known force and at most two unknown forces. So as I show you before, this is our truss, right? We will see how to analyze this truss using method of joints. First task is to find in support reactions. So you can see there are two supports. At A there is a pin support. If we have a pin support, we usually mark two force components, which are one horizontal force component and one vertical force component. You can see AX is the horizontal force component and AY is the vertical force component. If we have a rocker support, we usually mark one vertical force component. Here it marked as CY. Okay, now we will see how to find these support reactions. First, I am going to take moment about A to the counterclockwise direction. So if we take moment about A, I will have to consider this CY force and this 500 Newton force. So I will write the equation. CY is this force. So CY times 2. 2 is the distance to CY from point A or joint A. So if we consider the CY force, if I take moment of CY force, moment due to this CY force is counterclockwise direction. That's why I marked it here as plus CY. So if I consider this 500 Newton force, moment due to this force is clockwise direction. Therefore, I put minus sign here because I consider counterclockwise direction. So 500 is the this 500 Newton force, and 2 is this length to this 500 Newton force from point A. So if I simplify this, I can get CY equals 500 Newton. Next, I am going to take sum of vertical forces. So you can see there are two vertical forces, AY and CY. So I can write AY plus CY equals 0. Now I know value of CY, therefore I substitute value for CY. AY plus 500 equals 0. So if I simplify this, I can get AY equals minus 500 Newton. So this minus sign means this AY force is directed to downward, not upward. Next, I am going to consider sum of horizontal forces. So you can see there are two horizontal forces, AX and 500 Newton. So I will write it here, AX plus 500 equals 0. So these both forces are directed to the direction which we consider. So if I simplify this, I can get AX equals minus 500 Newton. Here also this AX force is acted opposite direction of this force, that means other direction, not this direction. So here you can see I marked correct directions. So AY is downward and AX is directed to the left side, right? And CY is correct because this is plus 500 Newton. We marked it upward and answer came as plus 500 Newton. So this is the correct free body diagram. So you can see CY equals 500 Newton, Ay equals plus 500 Newton and Ax equals plus 500 Newton. Next, we will see how to analyze this truss using method of joints. First, I consider joint B. So I will consider this joint B alone. So now I mark forces of this joint B. So first, this 500 Newton, it is given in a problem. So I marked it right here as 500 Newton. And this FBA is the force from this AB member. So I marked it downward. I will show you how I got these directions. And this FBC is the force from this BC member. So now we will look at how to decide these directions. So I will draw joint B here, and this 500 Newton is no problem, it is given in the original problem. So I will mark it as it is. Next FBC. So now I don't know the direction of FBC. I just draw a slope line. So this is FBC. So if I consider horizontal and vertical component of this FBC force, so I will draw it like this, right? So now you consider these two horizontal forces. So this 500 Newton force is acted these directions. So in order to keep the equilibrium, this force should be directed to opposite direction. That means this direction. Therefore we can determine, or we can decide, this force is directed to this direction. So now I can say this force also directed to this direction, and eventually this FBC force is directed to this direction. That's how I got this direction of FBC force. When I consider FBA, so now I know vertical component of FBC force is directed towards the joint. That means in order to keep the equilibrium, this FBA force must be acted to opposite direction. That means this direction. Therefore I mark FBA force away from the joint. So that means this downward direction. So that's how I decide directions of these two forces of these members. Okay, now I am going to find these forces. So first I am going to consider sum of horizontal forces. So if I consider horizontal forces, I will have to write 500 Newton force. So I wrote it here, and horizontal component of FBC force. So if I consider horizontal component of FBC force, I can write, so I will show you how I write FBC. So horizontal component is, so I know this angle, it's 45 degrees. Horizontal component is FBC sine 45. Vertical component is FBC cos 45, right? So if I consider horizontal forces, I have to write 500 minus FBC sine 45, which is horizontal component of this FBC force. So now I can simplify this and get the answer for FBC. For that I will have to use value of sine 45. So you can get values from this table. This is sine and this is 45 degrees. So I can write, instead of sine 45, 1 over square root of 2. So I will write it here, 1 over square root 2 as sine 45. If I simplify this, I can get FBC equals 500 square root 2 Newton. Next, I am going to take sum of vertical forces. So if I consider vertical forces, I have to write FBA and vertical component of FBC force. So if I write vertical force of FBC force, I can write FBC cos 45 and minus, because I consider upward direction, FBA is directed to downward direction, minus FBA. Now I already know value of FBC. I can substitute FBC value for this location. So I will substitute value for FBC and simplify it, and I can get answer as FBA equals 500 Newton. Next, I will show you how to mark member forces in this structure. So now I already know values and directions of this joint B. So you can see here. So according to Newton's third law, we can mark member forces in this diagram. So this force is acted downward. So in order to balance this force, there should be a force for upward direction. So I will mark force, upward force. So in order to balance this member, or in order to keep the equilibrium, there is a force for downward direction in this member. So in order to balance again this force, there should be force for upward direction from this joint. So this is joint A, right? And these are the three joints, right? So I will mark for your convenience. So this is joint A, and this is joint B, and this is joint C. So this is the support reaction of A, and this is the support reaction of joint C. So next I will consider this member, which is BC member. So in order to balance this force, there is a force for this direction. In order to balance this member, there should be a force for this direction. So now I will consider this joint. So here you can see there is a horizontal force. In order to balance this force, there is a force for opposite direction, which is this force. So likewise, I can mark all the forces. So I hope you understood what I show you. This whole system should be in equilibrium. So if we find one joint, if we find the forces of one joint, we can mark these all forces of these all members. Okay, this is a joint B, and you can see there is a new thing. So you can see here marked as tension, right? And this is compression. So we will see our members. So FBA is in tension. So this is FBA member. So you can see there are two forces directed away from this member. That means this member is in tension. So if we consider FBC member, it's in compression. So you can see this is the FBC member. So you can see and realize that this member is in compression. So there is a force for this direction, and there is a force for this direction. So due to these forces, this member is in compression. So that's how we determine, or that's how we decide tension and compression according to these member forces and their directions. So FBC, I found it before as 500 square root 2 and FBA as 500 Newton. Now I will consider joint A, this joint. So now I know this force, right? FBA force, and also these are the support reactions of this joint B. So only thing I don't know is FAC. So now I already know its direction, so it's tension. If I consider horizontal forces, it is obvious that you can see Fa is equals to 500 Newton. Now I know all the members because this force is here. This force is equals to this force. If I consider this member, this force is equals to this force, right? Therefore, now I know all the forces of this system. So that's how we analyze a simple truss using method of joints.